3.3. Solving equations with variables on both sides. In this lesson, you will be solving equations with variables on both sides, and this may lead to one solution, all solutions, or no solution. We all know by now that an equation involves a mathematical sentence formed by placing a symbol, the equal sign, between two expressions. The solution of an equation in one variable is simply a number that produces a true statement when substituted for the variable in an equation. Presentation and guided practice. Part A. Solving an equation with the variable on both sides. When we do this, our goal is to also combine like terms. So 5n and 3n are like terms. -2 and +6 are also like terms. And we need to combine them, but they happen to be on opposite ends of the equation. So let's first deal with the one with the variable. I would like to take the opposite of 3n and subtract it to both sides. I chose to do that because I don't want to deal with a negative number. 5 minus 3 gives me 2n. I can bring down the -2, cancel 3n and -3n, and this will give me +6. In the next one, I would like to combine -2 and 6. This may seem familiar. It's just a two-step equation now. Bring down the 2n. 6 plus 2 gives me 8. I'll rewrite it here. Divide by 2, divide by 2. N equals 4. Now we do the same thing for this one. I am going to choose to subtract 8y to both sides because I don't like to work with negative numbers. I'm going to bring down the 4. 11 minus 8 is 3. Y minus 17. And I'm going to add 17 to both sides. This gives me 21 equals 3y. Then I'm going to divide 3 to both sides. Cancel out the 3. 21 divided by 3 gives me 7. And here we have m and 9m. I'm going to subtract m to both sides. Bring down the -1. 9 minus 1 gives me 8m. Bring down +15. Okay, I'm going to subtract 15 to both sides. Bring down 8m. Get -16 on the left-hand side. Okay, I'm going to divide by 8. Because I need to solve for m, cancel out the 8, m equals -2. Part B. Now we're going to look at an equation with no solution. Okay, here on the left-hand side, we need to distribute the 5 into the sum of 2x plus 1. So 5 and 2x gives me 10x. Plus 5 times +1 gives me +5. recopy everything else. Now, I see that when I subtract 10x to both sides, I get 5 equal to 0. But that's not true. So, no solution. And here, let's take a look at another one. We need to distribute the 5 into the sum of 5t plus 1. So let's recopy the left-hand side. 25t plus 5. As you can see, we subtract 25t to both sides. 0 does not equal to 5. Again, no solution. Okay, now we're going to look at problems involving equations with all numbers as solutions. So here on the right-hand side, we can distribute the 2. 2 times 3x gives me 6x. 2 times positive 1 gives me positive 2. The left-hand side of the equation is exactly the same as the right-hand side, so we can just simply write all solutions. And for this one, we need to distribute the 7 into the sum of 2p plus 1. So 7 times 2p gives me 14p. 7 times positive 1 gives me positive 7. Again, we've got the same thing on both sides, so all solutions. Now in part D is a problem that involves geometry and algebra. It wants you to solve an equation to find a perimeter, or the perimeter. Okay. We know that this is a square. So you're given two expressions. Then I can set this expression equal to this expression. So 2x equal x plus 4. And now I can solve for x. Two minus 1 gives me 1x. Cancel out this part, bring down the 4. I can either substitute 4 into x plus 4 or 2x. It will give me the same answer, 8. And since there's 4 sides, I can just do 8 times 4. So my perimeter is 32. Okay. Now, in part E, I want you to write the verbal sentence as an equation and then solve the equation. 9 plus 2 times a number is equal to 2 less than 3 times the number. Okay, so 9 plus 2n equals 3n minus 2. I'm going to first deal with the variable. Bring down the 9. 3 minus 2 gives me 1, n minus 2. And then n would equal to 11. Now this one, 3 less than 11 times a number is equal to 9 plus 5 times the number. So again, 11n and 5n. So subtract 5n, so 6n minus 3 equals 9. But then we can add plus 3 to both sides. Bring down 6n, cancel out this part. 9 plus 3 equals 12, n equals 2. Toll booth. You lose your electronic tag that you use to pay tolls on the highway in your city. It costs you $24 to replace the tag. The cost of one toll when you don't use the tag is $3. The cost of the same toll when you do use the tag is $1.50. How many times will you have to use the tag to pay for the tolls in order for the total cost to be the same as not using the tag? So we can let S equal the number of times. So here you have your equation. How many times will you have to use the tag to pay for the tolls in order for the total cost of using tag to be the same as not using the tag? So when you use the tag, it's $1.50 each. And you need to pay $24 for the tag, and that's a fixed cost. So $24 plus 1.5x. And when you don't use the tag, it's $3 every time. So 3x. Now I can solve for x. Shift the decimal. So it's 240 over 15, and we can simplify this with 5. 15 divided by 5, 3, 240 divided by 5, 48, and then 16, so 16 times. So as you can see, this word problem, your goal is to set up an equation that involves variables on both sides of the equation. Shopping. You spend $60 on clothes and buy 3 DVD movies. Your friend spends nothing on clothes and buys 8 DVD movies. You both spend the same amount of money. All the DVDs cost the same amount. How much does each DVD cost? So let X equal the cost of each DVD. And your equation will simply be your spending, which is $60 plus 3 DVDs, so 3x, and this would equal to 8x. So here, this is you, and this is your friend. Because it says in the paragraph that you both spend the same amount. So that's why I put an equal sign here. Now we can solve for x. And x will equal to $12 per DVD. And that concludes our lesson.